the universe is not as still as it appears. In the velvet silence of the cosmic void, humanity has long sought comfort in the belief that we are drifting through an elegant, predictable dance, a slow outward expansion dictated by the fading echoes of the Big Bang. We view the stars as fixed points, the constellations as eternal guardians of the night. But beneath this visible tapestry, beneath the familiar, spiraling arms of the Milky Way, there flows a hidden current. A silent, colossal river of gravity is carrying us away. In the grand architecture of the heavens, the Earth is not merely drifting, it is being hunted. Everything known to our species, the warmth of our sun, the 100 billion stars of our galaxy, and the tens of thousands of neighboring galaxies that comprise our local supercluster, is in frantic, coordinated motion. We are racing at a staggering 2.2 million kilometers per hour toward a destination that remains stubbornly invisible. Somewhere, shrouded behind the zone of avoidance, that impenetrable veil of gas and dust at the heart of our own galactic disk, lies an anomaly of such staggering mass that it defies the traditional laws of cosmic expansion. This is the Great Attractor. It is a ghost in the machinery of space-time, an invisible anchor pulling an entire sector of the universe toward an unknown fate. As we hurtle through the dark, we must confront a chilling reality. The primordial expansion of the universe is being countered by a localized will of unimaginable proportions. We are caught in a gravitational grasp that began eons ago, a silent migration toward a shadow. It is a reminder that the map of the cosmos is not what it seems, and we are but passengers on a ship caught in an irresistible tide. The mid-20th century was an era of cosmic confidence. Astronomers, armed with the legacy of Edwin Hubble and the nascent power of digital spectroscopy, believed they had finally decoded the rhythm of the universe. The prevailing orthodoxy was one of the Hubble flow, a majestic, uniform expansion where every galaxy retreated from every other galaxy in a predictable, linear fashion. In this model, the universe was a balloon being inflated by a steady, invisible breath, and every point on its surface moved outward with a mathematical grace. It was a vision of a tidy cosmos, governed by a singular, outward momentum that left no room for deviation. But as the 1970s bled into the 1980s, the data began to whisper a different story, one of descent and irregularity. As spectrometers were trained on the distant reaches of the heavens, measuring the redshift of light to determine how fast galaxies were fleeing from us, a troubling pattern emerged. The expansion was not smooth. In certain sectors of the sky, galaxies were not just retreating, they were drifting. They were sliding sideways, caught in a current that the Hubble flow could not explain. It was as if a grand cosmic river was flowing through the expanding void, and our entire neighborhood of space was being swept up in its tide. In 1986, this atmospheric tension in the scientific community culminated in a landmark revelation. A collective of 7 astronomers, later dubbed the Seven Samurai for their bold challenge to cosmic orthodoxy, published findings that would forever alter our understanding of our place in the void. These men, David Burstein, Roger Davies, Alan Dressler, Sandra Faber, Donald Lindenbell, Roberto Turlevich, and Gary Wegner, were not looking for a monster. They were simply trying to map the distribution of elliptical galaxies to better understand the expansion rate of the universe. They sought to refine the constant, but instead, they found a violation. What they discovered was a phenomenon they termed peculiar velocity. While the universe was indeed expanding outward, the Milky Way and its celestial companions, including the Andromeda Galaxy and the entire local group, were possessed by a secondary motion. We were moving too fast. More importantly, we were moving in the wrong direction. We were not merely riding the wave of the Big Bang's expansion, we were being pulled off course by a localized tug-of-war. The 7 Samurai realized that our corner of space was being hijacked. This discovery was born from the womb of accident, a byproduct of a routine census of the stars. It suggested that somewhere across the vast, light-year-spanning gulfs of the cosmos, a massive concentration of matter was exerting a gravitational influence so profound that it could counteract the literal expansion of space-time. This was not a minor nudge. It was a colossal drag, a gravitational anchor cast into the deep. The data indicated that this unseen influence was drawing us toward a specific coordinate in the direction of the Centaurus and Hydra constellations. But as the samurai turned their gaze toward this mysterious source of gravity, they encountered a wall. The source of our celestial migration lay hidden behind the zone of avoidance. This is the region of the sky obscured by the thick, opaque disk of our own Milky Way. The very stars and gas clouds that form our home were acting as a cosmic blindfold, preventing us from seeing the entity that was pulling us toward it. We were like sailors in a dense fog, feeling the ship accelerate toward a rocky shore we could not see, blinded by the very vessel that carried us. The search for the Great Attractor had begun, but it was a hunt for a ghost, a phantom of mass and light that sat in the darkest, most unreachable corner of our perspective. The scientific community was left in a state of profound disorientation. If the universe was supposed to be a smooth, expanding fabric, what could possibly be heavy enough to tear a hole in that logic? The seven samurai had identified the symptoms of a cosmic sickness, but the cure, the visual confirmation of what lay at the end of our trajectory, remained elusive. We knew we were moving. We knew we were being pulled. But the identity of our attractor remained a mystery, locked away behind a veil of galactic dust, leaving humanity to wonder if we were heading toward a sanctuary of mass or a gravitational abyss from which there is no return. The realization that our entire galaxy was a minor participant in a much larger, invisible drama brought a new sense of fragility to our existence. We had spent centuries mapping the stars, believing we were the masters of our orientation. Yet, in a single decade, we learned that we were merely leaves caught in a gale, traveling at millions of miles per hour toward a destination we had only just begun to name. The Hubble flow was no longer a simple law. It was a background noise, and over that noise, we could now hear the heavy, rhythmic thrum of the Great Attractor. The revelation of the Great Attractor did more than merely add a new coordinate to our celestial maps. It shattered the glass of cosmic perfection. For decades, the foundation of modern cosmology rested upon a singular, elegant pillar known as the cosmological principle. This principle dictated that on a sufficiently large scale, the universe must be homogeneous and isotropic, a grand, smooth expanse where matter and energy are distributed with democratic fairness. In this view, the cosmos was a flawless fabric, stretching uniformly in every direction, devoid of any one place that could claim preference or power over another. It was a vision of a balanced universe, born from the cooling embers of the Big Bang, where the expansion of space itself was the only true protagonist. But the Great Attractor was a heresy. It suggested that the universe was lumpy on a scale that defied every established mathematical model. It was a mountain of gravity rising out of a supposedly flat plane, a titanic concentration of mass that simply should not exist if our understanding of the early universe was correct. To the scientific community, the existence of such a structure was not just a curiosity, it was a crisis of logic. If the universe was truly uniform, how could tens of thousands of Milky Ways find themselves gathered in a single, invisible point of influence? The shock that rippled through the halls of physics was rooted in the sheer, staggering scale of the anomaly. We were looking at a gravitational shadow equivalent to quadrillions of suns, a concentration of mass so dense it warped the local trajectory of every galaxy within its reach. This was not a localized cluster or a passing alignment of stars. This was a continental-sized fracture in the smooth facade of the cosmos. For something to exert a pull across 250 million light-years of void, it would have to be the most massive structure ever conceived by the human mind. It was a gravitational titan that made our entire galaxy seem like a leaf caught in the draft of a passing freight train. The implications for our origins were equally unsettling. The early models of the Big Bang, supported by the faint afterglow of the cosmic microwave background, suggested that the primordial soup of the young universe was almost perfectly even. While small fluctuations existed, seeds that would eventually grow into galaxies, they were never expected to produce a monster of this magnitude. The Great Attractor contradicted the timeline of cosmic evolution. It was as if we had discovered a fully formed city in a strata of Earth where we only expected to find single-celled organisms. It suggested that gravity had worked faster or more aggressively than our theories allowed, pulling matter together into a colossal, unauthorized architecture while the rest of space was still trying to find its form. Scientists struggled to reconcile this invisible something with the literal expansion of space-time. Since the discovery of redshift, we had known that the universe was fleeing from itself, that the distance between galaxies was growing as the fabric of space stretched. This expansion is the dominant force of the cosmos, a relentless outward pressure that should, in theory, isolate galaxies from one another over vast distances. Yet, the Great Attractor was counteracting this flow. It was a localized rebellion against the expansion of the universe. It was a gravitational anchor, cast into the deep, holding back 1,000 galaxies from their outward flight. This realization introduced a profound sense of scientific vertigo. If the expansion of the universe could be hijacked by a localized mass, then our predictions for the future of the cosmos were suddenly cast into doubt. We began to realize that we were not living in a smooth, predictable inflation, but in a landscape of jagged peaks and deep valleys. We were sliding down a gravitational slope, drawn toward a center that we could not see and could not explain. The Hubble flow, the once sacred measurement of cosmic retreat, was being muted by the heavy, rhythmic thrum of this unseen attractor. The mystery deepened when physicists looked at the distance involved. Gravity is a force that weakens with the square of the distance, a law that usually ensures that the influence of even the largest objects is confined to their immediate neighborhood. But the Great Attractor was reaching out across the light years, crossing the vast, empty deserts of the intergalactic void to touch us. It was as if a magnet in London were pulling a needle in New York. This suggested that the structure was not just large, but fundamentally different in its composition. A dark, dense scaffolding that perhaps consisted of more than just the stars and gas we could observe. This scientific shock forced a recalibration of our cosmic humility. We had spent the 20th century believing we had finally grasped the big picture, a smooth, expanding bubble of light. But the Great Attractor revealed that we were only looking at the surface of the water. Beneath the surface, in the dark depths of the gravitational ocean, there were currents and monsters that our theories had never accounted for. We were forced to accept that the universe possessed a hidden architecture, a dark blueprint of mass that governed our movement while remaining entirely beyond our visual reach. As astronomers began to grapple with this violation of the Hubble flow, a new question emerged, one that was more philosophical than mathematical. If we are being pulled by something we cannot see, and that pull is stronger than the expansion of space itself, then what is the ultimate destination of our journey? Is the universe destined to remain a fragmented collection of drifting islands, or are we part of a grand, inevitable convergence? The Great Attractor was the first piece of evidence that the story of the universe might not end in a cold, lonely expansion, but in a final, crowded embrace at the heart of an invisible titan. The struggle to accept the Great Attractor was, in many ways, a struggle to accept our own insignificance. We wanted a universe that was orderly, a cosmos that followed the clean, geometric lines of the cosmological principle. Instead, we found ourselves in a universe of shadows and secrets, a place where the most powerful force in our sky was a ghost we couldn't even name. The shock of discovery was replaced by a quiet, persistent dread, the realization that the most important part of the universe is the part we cannot see, and it is that invisible hand that is currently deciding our fate. For decades, the Great Attractor remained a phantom, a gravitational ghost haunting the periphery of our understanding. It occupied a region of the heavens that seemed intentionally shielded from human curiosity, a place astronomers call the zone of avoidance. This is not a physical barrier of stone or steel, but a thick, suffocating veil of gas, stars, and interstellar dust that constitutes the disk of our own Milky Way. From our vantage point within this celestial spiral, we are blinded by our own home. Approximately 20% of the extragalactic sky, the very region where our destiny appears to be written, is swallowed by the opaque brilliance of our galaxy's heart. To look toward the Great Attractor is to try and see a distant candle through a raging forest fire. For a long time, this blindness was absolute. Visible light, the the medium through which humanity had navigated the stars for millennia, is easily scattered and absorbed by the fine soot of space. In the optical spectrum, the direction of the Centaurus and Hydra constellations was a wall of shadows. But the laws of physics provide other windows into the deep. To see the invisible, humanity had to build eyes that could perceive the world beyond the narrow sliver of the rainbow. We had to transcend the limitations of biological sight and embrace the long, patient whispers of the electromagnetic spectrum. The investigation began in earnest when astronomers turned toward X-ray astronomy and radio waves. Unlike visible light, these high-energy and long-wavelength signals can navigate the labyrinth of the Milky Way's dust clouds, slipping through the gaps between atoms to reach our detectors. It was through the eyes of instruments like the Parkes Observatory in Australia and orbiting X-ray telescopes that the fog began to lift. What emerged from the darkness was not a singular, monstrous object, nor a lone supermassive black hole of impossible proportions. Instead, scientists glimpsed a sprawling, crowded metropolis of matter. Hidden behind the veil, they discovered a gargantuan concentration of galaxies known as the Norma Cluster. This was a city of stars, a place where gravity had pulled together hundreds of galaxies into a dense, chaotic swarm. Located near the very heart of the attraction, the Norma Cluster provided the first tangible evidence of why our sector of the universe was in motion. Yet, as the data was processed and the masses were calculated, a new and more profound silence fell over the scientific community. The Norma Cluster, as magnificent and terrifying as it was, did not possess enough mass to account for the velocity at which the Milky Way was moving. It was a giant, but it was not the titan we were looking for. The math remained broken. The pull was too strong, the acceleration too frantic. This discrepancy forced a radical shift in perspective. Astronomers began to realize that they were not looking at a single point of attraction, but at a structural feature of the universe itself. The deeper the investigation went, the more the boundaries of our cosmic geography began to dissolve and reform. In 2014, using new techniques to filter out the expansion of the universe and focus solely on the peculiar motion of galaxies, a team led by Brent Tully revealed a structure of such staggering scale that it redefined our concept of home. They named it Laniakea, a Hawaiian term meaning immense heaven. Laniakea is a supercluster of galaxies, a vast, arterial network spanning 500 million light-years. It contains the mass of 100 quadrillion suns. In the visualization of this structure, the Great Attractor is revealed not as a solid entity, but as the lowest point in a colossal gravitational valley. Imagine a watershed on Earth, where every drop of rain falling over thousands of square miles eventually trickles down into a single, massive river. Laniakea is a cosmic watershed. Every galaxy within its invisible borders, including our own, is flowing down a gravitational slope toward a singular basin. The Great Attractor, we now understand, is the focal point of this flow. It is the drain at the bottom of our local universe. But even this realization brought a chilling sense of escalation. As we mapped the filaments of Laniakea, we saw that our supercluster was not an isolated island. It was a single branch in a much larger, more terrifying tree. The Norma Cluster and the Great Attractor were merely the inner harbor of a gravitational ocean that extended far beyond our ability to see. The investigation had moved from a search for a hidden object to the mapping of a cosmic current. We realized that we are part of a grand, celestial migration. The zone of avoidance had hidden the truth not just of what was pulling us, but of what we are. We are not a lonely galaxy drifting in a void. We are a small part of a vast, living architecture of gravity, a heavenly structure that is itself in motion. This deeper look into the dark revealed a universe that is far more organized and far more precarious than we ever imagined. The Great Attractor was just the tip of a cosmic iceberg, a hint of a hidden mass that suggests the very vacuum of space is threaded with invisible scaffolding. As we peered through the dust of the Milky Way, we didn't just find a cluster of galaxies. We found the pulse of the cosmos. We found that the universe has a shape, a direction, and a destination. And as we continue to hurtle down the slopes of the Laniakea watershed, we are left to wonder, What happens when we finally reach the bottom? What lies at the end of the current, where all the rivers of the immense heaven finally meet? The discovery of Laniakea changed the mystery of the Great Attractor from a question of what to a question of where. We are no longer looking for a monster in the dark. We are realizing that we are part of the monster. The peculiar velocity noticed by the Seven Samurai was the first hint of our participation in this grand, silent movement. But as the map of Laniakea became clear, a new shadow appeared on the horizon. The flow lines did not stop at the Great Attractor. They suggested a pull from even further away, a gravitational summons from a distance so vast it threatened to break our understanding of space and time once again. The hunt for the source of our motion was far from over. It was merely expanding to a scale that the human mind was never designed to comprehend. The resolution of our cosmic maps brought with it a new kind of dread. For years, the Great Attractor had served as the ultimate protagonist in our story of celestial motion, a singular, hidden titan sufficient to explain the frantic pace of our galactic journey. But as the mathematics of gravity were refined, and as the weighing of the Norma cluster and its surrounding filaments became more precise, a chilling discrepancy emerged. The numbers, cold and indifferent, refused to align with reality. Even with its thousands of galaxies and its concentrated wells of dark matter, the Great Attractor lacked the sheer gravitational muscle required to move the Milky Way at 2 million kilometers per hour. It was a massive engine, certainly, but it was not powerful enough to drive a current that spanned the breadth of the Laniakea supercluster. The mystery had not been solved. It had merely been unmasked as a symptom of something far more vast. If the Great Attractor was the drain at the bottom of our local valley, then we were beginning to realize that the valley itself was perched on the edge of a much steeper, more terrifying cliff. The peculiar velocity observed by the Seven Samurai was too extreme, too coordinated. It suggested that the Great Attractor was not the final destination, but merely a transit point, a way station on a journey toward a horizon we had not yet dared to imagine. The math demanded a larger ghost. It demanded a structure of such staggering proportions that it could exert a pull across distances that make a light year seem like an inch. In the late 1980s and early 1990s, as astronomers looked deeper into the void, beyond the Great Attractor and across a gulf of 650 million light-years, they found the true architect of our motion. They discovered the Shapley Supercluster, a gargantuan wall of matter, a cosmic continent so massive it redefines the very meaning of the word structure. Named after Harlow Shapley, the astronomer who first caught glimpses of this density in the 1930s, this is the most massive concentration of galaxies in the observable universe. It is a city of thousands upon thousands of star systems, packed so tightly together that they create a gravitational field that warps the very fabric of the cosmic expansion across a significant fraction of the sky. The realization was as profound as it was unsettling. We are caught in a multi-stage cosmic drain. The Milky Way is falling toward the Great Attractor, but the Great Attractor itself is falling toward the Shapley Supercluster. This is not a simple tug-of-war, it is a grand, cascading migration. We are witnessing what astronomers call a bulk flow, a coherent movement of matter where hundreds of millions of light-years of space are sliding in unison toward a singular, distant concentration. We are no longer looking at a local anomaly, we are looking at the pulse of the cosmic web itself. This revelation transformed our understanding of the universe from a collection of isolated islands into a titanic, interconnected machine. If the Big Bang provided the initial outward momentum, the Shapley Supercluster represents a localized defiance of that origin. It is a gravitational behemoth that has gathered enough mass to begin drawing the universe back into itself. In the face of such a structure, the Milky Way, with its hundreds of billions of stars, its ancient nebulae, and its storied history, is reduced to a single grain of sand caught in a hurricane. We are part of a celestial watershed that spans a significant portion of the observable universe, a region where every path, every orbit, and every destiny is being corrected by the overwhelming weight of the Shapley Wall. The sheer scale of this bulk flow suggests that the universe is organized into filaments and voids of unimaginable dimensions. We are drifting along one of these filaments, a cosmic thread woven from galaxies and dark matter, being pulled through the dark toward a convergence point that sits at the very edge of our mathematical models. The mystery of our motion has escalated from a question of what is behind the dust to how can the universe sustain a structure this large? According to the standard models of cosmology, matter should be more evenly distributed over such vast distances. The existence of the Shapley Supercluster and its ability to hijack the motion of our entire sector of space poses a direct threat to our understanding of physics. It suggests that gravity has had more time or more help from the invisible hands of dark energy and dark matter to build these monuments of mass than we ever believed possible. As we contemplate our slide toward this distant wall, a sense of philosophical vertigo takes hold. We have spent centuries looking at the stars, believing we were seeing a static or uniformly expanding heaven. Instead, we find ourselves in the midst of a grand, silent exodus. We are moving toward a meeting place of galaxies, a final gathering of mass where the laws of physics as we know them may reach their breaking point. The Shapley Supercluster is a reminder that the universe is not a finished product, but a living, breathing architecture of gravity that is still under construction. We are witnesses to a process that began billions of years ago and will continue long after our sun has faded into a white dwarf. The Great Attractor was merely the first chapter of a story that now encompasses the entire visible horizon. We are part of a migration that spans the darkness between the stars, a journey driven by an invisible force toward a destination that is as terrifying as it is magnificent. As we hurtle through the void, we must ask, are we moving toward a new beginning, or are we simply part of the inevitable collapse of a universe that has finally begun to feel the weight of its own creation? The discovery of the Shapley Supercluster has pulled the veil back further than we ever intended. It has shown us that the immense heaven of Laniakea is just one room in a much larger, darker house. We are no longer just looking for a source of gravity, we are looking at the very backbone of reality. And as we continue to measure the speeds of distant galaxies and the depths of the cosmic voids, we find that the current is only getting stronger. The universe is not just expanding, it is falling, and we are falling with it. The architect of the cosmos is a silent one. As we stand on the precipice of the Great Attractor's influence, staring into the heart of the Laniakea supercluster, a fundamental question echoes through the void. How does a structure of such devastating magnitude form in a universe that began as a near-perfect, smooth radiation? The answer, it seems, lies not in the light of the stars we can count, but in the crushing weight of the shadows we cannot see. The leading theories that attempt to reconcile the Great Attractor's pull with our understanding of physics point toward the cold dark matter model, the invisible scaffolding upon which the entire visible universe is draped. In the standard model of cosmology, baryonic matter, the atoms that compose our bodies, our planets, and the glowing nebulae of distant galaxies, is merely the foam on the crest of a much deeper, darker ocean. There is simply not enough normal matter within the Norma cluster or the surrounding filaments to account for the gravitational hijacking of the Milky Way. To explain the Great Attractor, we must invoke an immense, localized concentration of dark matter. This substance, which does not interact with light but dictates the motion of all things through gravity, acts as the cosmic glue. It is theorized that in the earliest moments after the Big Bang, dark matter began to clump together into halos, creating deep gravitational wells. Over billions of years, these wells lured in the wandering gas and dust of the young universe, birthing the galaxies we see today. The Great Attractor is, in this view, a massive, primordial knot in the dark matter web, a concentrated nexus where the invisible skeleton of the universe is at its most dense and demanding. Yet, as sophisticated as the dark matter model may be, it remains a theory of pull. In recent years, a new and perhaps more unsettling speculation has emerged, the dipole-repeller theory. This model suggests that the Milky Way's frantic pace is not solely the result of an attraction ahead, but also a repulsion from behind. Imagine a boat in a river, accelerated not just by the waterfall downstream, but by a powerful surge from upstream. Mapping the velocities of thousands of galaxies has revealed a vast, underdense region on the opposite side of our local sky, a cosmic void of unimaginable proportions. This void, lacking the mass of galaxies and dark matter, acts as a gravitational repellent. While the Great Attractor pulls us, this dipole repeller pushes us. We are caught between a titan of mass and a titan of nothingness, squeezed through the cosmic vacuum by the combined forces of the universe's most crowded and most empty places. But even these explanations may only be scratching the surface of a deeper fracture in our reality. Some physicists have begun to question the very tools we use to measure the heavens. They wonder if what we perceive as the Great Attractor is actually a signature of a flaw in Einstein's general relativity when applied to the macro scale. Perhaps gravity does not follow the inverse square law across hundreds of millions of light-years. Perhaps, over these titanic distances, the fabric of space-time behaves differently, creating anomalous accelerations that our current mathematics cannot yet describe. It is a haunting possibility that the Great Attractor is not a thing, but a symptom of our incomplete understanding of the very nature of space. Others look toward even more exotic origins, such as primordial black holes, remnants from the first fraction of a second of existence. If enough of these ancient, invisible singularities congregated in a single sector of space, they could create a gravitational engine powerful enough to move an entire supercluster. There are even whispers of dark flow, the idea that the motion we observe is being dictated by matter that exists outside the borders of our observable universe. If the inflation of the universe created multiple bubbles, or a multiverse, the gravitational influence of a neighboring universe could be tugging at the edges of our own through a form of cosmic quantum entanglement. We would be feeling the weight of a world we can never visit, a shadow cast across the dimensions. As we sift through these theories, the mystery of the Great Attractor becomes a mirror for our own philosophical limitations. Whether it is a knot of dark matter, the push of a void, or the tug of a parallel reality, it serves as a reminder that the universe is governed by forces that remain largely inaccessible to the human senses. We are living in a house where the most important supports are invisible, and the most powerful influences are the ones that never speak. The Great Attractor is the ultimate testament to the dark universe, a place where light is the exception and the silent, heavy work of the cosmos happens in the spaces between the stars. We are left to wonder if we will ever truly see the face of our attractor, or if it will remain a mathematical ghost, a necessary variable in the equation of our survival. Every theory we propose is a bridge built into the dark, an attempt to rationalize a journey that began before the stars were born and will end in a destination we are only just beginning to name. In this grand, speculative dance, the only certainty is the motion itself. We are moving because the universe demands it, drawn forward by a blueprint of gravity that was written in the shadows long ago. The pursuit of the unseen is a task that requires more than just vision. It requires a radical reconstruction of reality through the language of mathematics and the cold, unblinking eyes of our most advanced technology. Humanity is no longer content to merely feel the pull of the Great Attractor. We have begun the painstaking process of measuring the invisible threads that bind us to it. This modern odyssey is being led by the ambitious Cosmic Flows Project, a monumental effort to chart the three-dimensional movement of the universe. By tracking the peculiar velocities of over 8,000 galaxies, researchers are essentially mapping the currents of a cosmic ocean, identifying where the water stands still and where it begins to race toward a hidden drain. Through these efforts, the vague outlines of our celestial neighborhood have finally crystallized into a definitive structure. We now know the boundaries of our home, Laniakea. By calculating the points where galaxies cease to move toward the Great Attractor and instead begin to fall toward a different gravitational center, scientists have defined the borders of this immense heaven. Laniakea is not just a collection of stars. It is a gravitational watershed, a territory of space defined by a shared destiny. Every star within these 500 million light-years is part of the same silent migration. The data from the Gaia mission, which has provided the most precise positions and motions of billions of stars, acts as the foundational ledger for this celestial census. It is a record of a civilization realizing, for the first time, exactly where its house sits on the map of the infinite. Yet, even with these maps, a vast portion of the story remains hidden. To truly understand the engine of our motion, we must look through the very heart of our own galaxy, the zone of avoidance. This is where the Square Kilometre Array, or SK, enters the narrative. Currently under construction as one of the largest scientific endeavors in human history, the SKA will not look for the light of stars, but for the faint, ancient radio whispers of hydrogen gas. Radio waves possess a unique ability to slip through the thick, suffocating dust of the Milky Way's disk like a ghost through a wall. When fully operational, the SKA will provide the most detailed radio map of the hidden sky ever created, finally stripping away the veil that has blinded us since the dawn of astronomy. We are preparing to look into the eye of the storm, to see the Norma cluster and the density of the Shapley Supercluster with a clarity that was previously impossible. The central question driving this technological crusade is one of permanence. Is the Great Attractor our final destination, or is it merely a transit point? Scientists are meticulously measuring the acceleration of every nearby galaxy to determine the ultimate outcome of this cosmic tug-of-war. On one side is the Hubble expansion, the relentless outward pressure of dark energy that seeks to pull the universe apart. On the other is the localized pull of the Great Attractor and the Shapley Supercluster, seeking to draw matter together into a singular, catastrophic embrace. To find the answer, astronomers are using the light of distant quasars, the brightest beacons in the universe, as fixed reference points. By observing how our local group of galaxies moves relative to these ancient, stable lights, we can see if the current is accelerating or slowing down. There is a profound, speculative tension in this data. Some models suggest that as the universe continues to expand, the distance between Laniakea and the Shapley Supercluster will eventually become so great that the expansion will win. In this scenario, the drain will eventually dry up and the galaxies will be carried away into an eternal, lonely dark. However, other theories suggest that the mass of the Shapley concentration is so immense that it has already decoupled from the expansion. In this darker vision of the future, we are destined for a localized big crunch, a final, crowded collapse where all the rivers of the Laniakea watershed finally meet in a singular point of infinite density. This ongoing testing is more than just an exercise in physics. It is a search for the expiration date of our world. Every new data point from our radio telescopes and every new velocity vector mapped in the cosmic flows is a sentence in the biography of our future. We are using the most sophisticated tools ever built to ask a question that has haunted the human spirit since we first looked at the stars. Where are we going? As the SK begins to scan the hidden horizons and the Gaia data continues to refine the motion of the heavens, we are moving closer to an answer. We are learning that the universe is not a static backdrop, but a dynamic, shifting landscape of energy and mass. A place where the very ground beneath our feet is sliding toward a horizon we are only just beginning to understand. The search for the Great Attractor has evolved from a mystery into a mission. We are no longer passive observers of our fate. We are the cartographers of our own exodus. By measuring the peculiar velocities of the stars, we are attempting to calculate the weight of the invisible and the direction of the unknown. And as the maps of Laniakea become more detailed, we find that the more we know about our destination, the more we realize how much of the journey remains a mystery. We are the witnesses to a migration that spans the eons, armed with the tools of the future to decode a blueprint written in the ancient past. The story of the Great Attractor is not merely a chapter in an astrophysics textbook. It is a profound mirror held up to the collective soul of humanity. We spend our brief lives building civilizations, forging nations, and etching our histories into the crust of a planet we perceive as a bedrock of stability. We walk our streets and look at our horizons with a sense of permanent orientation, unaware that the very ground beneath our feet is a vessel caught in a silent, cosmic gale. In the grand hierarchy of the heavens, the human ego is a fragile thing. To realize that the Milky Way, a colossal structure of 400 billion suns, is merely a single leaf swept up in a gravitational current is to confront the true scale of our insignificance. We are passengers on a journey we did not choose, hurtling through the dark toward a destination that remained hidden from our sight for the entirety of human existence. As we peer through the technological windows we have built, looking toward the obscured heart of the zone of avoidance, the illusion of isolation finally dissolves. For centuries, we viewed the universe as a collection of lonely islands, drifting through an infinite and empty sea. But the Great Attractor has revealed the existence of a deeply interconnected web of influence, a dark, invisible scaffolding that binds the furthest reaches of the cosmos into a single, breathing organism. We are not drifting in a vacuum. We are part of a grand migration, a celestial pilgrimage of matter and light toward a center of gravity that may always remain just beyond our reach. The Great Attractor stands as the ultimate symbol of the unknown, a reminder that in the vastness of space, there are forces that dwarf our greatest intentions and our most advanced understandings. It is a titan of shadow that dictates the path of every star, yet it asks for no witness and offers no explanation. There is a haunting beauty in this realization. As the expansion of the universe attempts to pull us into an eternal solitude, the Great Attractor and the Shapley Supercluster pull us back, demanding a convergence. This is the ultimate cosmic tension, a struggle between the force that wants to tear the universe apart and the force that wants to bring it back together. We exist in the middle of this gravitational tug-of-war, living our lives in the brief moment of equilibrium between the outward flight and the inward fall. Our scientific instruments may measure the peculiar velocity of distant clusters and the density of dark matter, but they cannot measure the weight of the awe that comes with knowing we are part of such a majestic architecture. We conclude this journey not with the cold paralysis of fear, but with a renewed sense of wonder. The very fact that a biological consciousness, born on a small rock orbiting an unremarkable star, can perceive the invisible hand of the Great Attractor is a testament to the flickering, miraculous spark of human intellect. We have looked into the shadows and found a structure. We have felt a pull and named its source. In a universe dominated by the dark and the silent, we have dared to draw a map of our own exodus. The Great Attractor may be the master of our trajectory, but it is not the master of our curiosity. As the Milky Way continues its 2 million km/h slide down the slopes of the Laniakea watershed, we remain the witnesses to the migration. We are the eyes of the universe looking back at itself, trying to understand the current that carries us. Perhaps we will never reach the heart of the attraction. Perhaps the expansion of space will eventually win, carrying the galaxies into a final, lonely dark where even the light of our neighbors can no longer reach us. But for now, we are together. We are part of a cosmic flow that spans the eons, a journey through the immense heaven toward a mystery that defines the very essence of reality. In the end, we are just travelers in the night. Find comfort in the fact that even in the deepest void, we are never truly drifting alone.